Hello and welcome back to the lecture of time series econometrics. By now, when you're talking about all these AR models, MA models, random walk, and of course starting from white noise, it is quite likely that you might be a little confused about these different concepts and their mathematical properties and how they're related. Okay, so this session is specifically for that, to kind of bring all these different processes and to bring a comparison between these processes and to understand how one is different from the other. Okay, so let me show you a data sheet. So here we can see this is a white noise process. Okay, so all these values that we see, the white noise is basically they're IID. Okay, so they are all independent, identically distributed with a mean 0 and variance sigma square. Okay, now from this white noise, we told you that from white noise we basically create MA, AR, or a random walk. So from this white noise, we are required to create a MA process, MA1 process, with its theta operator as a 0.9, and a AR1 process with its phi operator 0.9. We deliberately kept this value same so that we see actually what the differences are, and then a random walk process. Okay, so that's what we are going to do now, to basically create a MA1, AR1, and a random walk process from the given white noise process. So let us try to recall the formula for MA1 process and for the AR1 process first, because that is the first thing where we might be a little confused. Okay, so let me write down the formula for MA1 process. So for MA1 process, how we write is, for MA1 process, we write YT is equal to ET plus theta ET minus 1, right? Whereas for an AR1 process, we write YT is equal to YT minus 1 plus, so I have to put a phi operator plus some ET. Okay, so that's basically the difference between the MA1 process and AR1 process, and how exactly that I interpret that. So we'll just see that from the data. Okay, so let us go back to the data. Now in this data, so what will happen is, suppose now I'm considering a MA1 process. The first process is the same, right? The first process, you don't have any past, nothing, so you can just simply write this is equal to this. Okay. In the second process, in MA1 process, what is happening is your ET for the second period is ET, the ET value remains same, so which is basically this, and you take into account the previous period, and you have a value of your theta operator 0.9. So let me just write down 0.9 into this. So I get this value for MA1 process, right? Let me write down the AR1 process here. I'm just taking first two period, and then we'll see for the next period how they're different, similar. Okay. So for AR1 process also, for the first period, you don't have nothing to do basically. So you simply write the first period value, and in the second period, what you do is again this plus your phi operator 0.9 into this value. Okay, so bring in here. So they're basically same. For the for 0th lag or the fast lag, they're basically the same values. Okay. Now, if I now consider MA1 process at period equal to the next period, basically, I will write equal to this value. Now, look at it carefully. What I'm doing here is 0.9, and the value I take here is basically this value, the previous period. So these are my ETs, right? The values that you see below the white noise series, they're basically my ETs for different period. So in my third period, I have the value, the ET value corresponding to third period, and I take theta into the value, the white noise value in the second period, right? So here I get minus of 1.57. Now here we see the difference a little carefully. So here also I take the ET, okay? But my my phi operator 0.9 is actually multiplied with yt minus 1, not et minus 1. So it is yt minus 1. So if it is yt minus 1, I write this here. Okay, so now you see the difference. Now there is a difference between the value of moving average and AR1 process. Okay, similarly, now if you get this concept clear, so it's all clear now onward. So let me write down the next period. What will happen is you simply take this, you take this, you take 0.9, you take the previous period value, which will mean this, whereas this will differ, of course. And initially I'm taking the ET value, though in my equation I'm writing ET the last, but for the sake of ease of operation, let me just write like this into this, something previous period value, and this is going to be this. So they're quite different, you see. Similarly, this plus 0.9 into this, and I will write this plus 0.9 into this. Okay, so I get these values MA, and similarly for AR I get these values. For AR, what I'll do here again, I'll take this error value into a phi operator, then take previous period value, and I get this, whereas for this period I take the error and 0.9 into the previous period value. So I get all the values like this. Okay, so now you see for the first two periods we had the MA and AR, they had basically the same values, because in that case, in the first period, your YT, the equation that you've just written, your YT and your ET, there. So basically, this ET minus 1 and YT minus 1, they're basically the same as long as I'm dealing with only the first and second period, right? For a MA process of order 1 or AR process of order 1, okay? So because of that, we are actually getting the values, first two period values the same for AR and MA, whereas for the values onward, they're going to differ. Now, what will happen for the random walk? Let us now consider the random walk. Random walk is very simple. We know that if we writing a random walk without a drift, so it is simply, I will just add the values of the, say, these values, right? So I can just create a formula sort of thing. I can just this, and I think if I pull it down, it will repeat the formula. So I'll get these values, the random walk values. Okay. So this is how my AR, MA, and random walk, when you construct this from a white noise, this is how they're going to differ. Okay. In the next lecture, I'm going to give you an example illustrating these differences.